Hi everyone. So today you are watching the first part of our spring final exam study guide review video. I'm going to be posting these videos periodically as I finish them, probably in about 30-minute increments, going through the study guide so that you can review and prepare for your test. This has been a crazy year and a crazy semester, so we just want to make sure that you have everything you need to be successful. So we're going to start with Unit 1, and with Unit 1, which we started way back in January, the first thing we started with was reviewing and reminding ourselves how to read a chemical equation. So remember, a chemical equation is made up of the symbols and letters and numbers that represent the chemicals, the amount of chemicals, that represents the chemicals and the amount of them that are used in a chemical reaction. What chemicals do you start off with? What chemicals do you end up with? And so for these labels, okay, when we look at label A, which is pointing to this number 2, that is a coefficient, okay? And so with a coefficient, they always belong in this beginning part in front of your chemical formula. And if there's no number there, it's always assumed that there's at least one. And coefficients are always representing our moles. So for example, that says 2 moles of silver nitrate, or AgNO3. Now, speaking of that number 3, letter B, that 3 is an example of a subscript. It tells you the number of atoms that there are. And again, if there's no number, it's 1. If you look at label C, it's pointing to the arrow. Now, the arrow separates your reactants from your products and is representing the word yields, or also the word produces, makes, anything that's separating what you have and what you're creating or what you're making. So as a reminder, your reactants are always on the left side, and they react to make, to yield, to produce, to form your products. Now, with letter D is pointing to this S in parentheses, and you see that there was another one earlier with copper. This is telling you the state of matter, or the fact that the silver is a solid. When you see AQ like this, that would mean that it's aqueous. Now, if you don't remember what the word aqueous means, it means that it was originally a solid, but they dissolved it in water so that they could mix it with other chemicals. Now, 2 words that were in your study guide that did not have labels are gas and liquid. We didn't see them in this particular example. So if you were to see, for example, a chemical like H2O or water with a G in parentheses after it, that G would be telling you that it's a gas. If you were to see H2O with an L next to it, that L is telling you it's in the liquid form. So a parenthesis with a letter in a chemical equation is telling you about the state of matter. So solid, liquid, gas, aqueous, that is the state of the chemical. And so one thing we talked about was how to change these chemical equations into sentences that they are representing, which is basically how you would say it out loud. You would not read this and say 2AgNO3 parenthesis AQ parenthesis plus 1. That's not how you would actually say it out loud if you were quote unquote reading it. What you would do is, we know that the 2 represents our moles. So we would say that this equation has 2 moles of silver nitrate, which we did not focus much on naming our chemicals, so we're just going to keep with the symbols. And actually, I forgot, in chemistry and in most English language, the adjective comes before the symbol. So even though AQ is after the chemical formula in the equation, the word comes in front in the sentence. So it would be 2 moles of aqueous AgNO3, or silver nitrate. And then the plus symbol is going to be the word and. So, and 1 mole of solid copper. And then remember, the arrow means yields or produces or makes. So we can say 2 moles of aqueous silver nitrate and 1 mole of solid copper. We could say reacts to form, but we're just going to say reacts to produce. So they do react, and when they react, they produce 2 things. They produce 2 moles of solid silver, or Ag, and 1 mole of aqueous copper nitrate, or CuNO3 2. And this was the very first skill that we learned on the first or second day of school back in January. Now, what I want to remind you is when we're looking at this study guide and we're looking at our notes, if you're watching this video and you actually are in my class or in a chemistry class at my school, this subheading, this is the name of the skill in the gradebook. Okay, this is the name of the skill that's in the gradebook right now. So if you go look at your grades and you find the classwork grades, not the test grades, but if you find the classwork grades that are the lowest and you look at their name, you will find a heading with that name in this study guide. And you can focus your attention on making sure you get tutoring and that you really understand those skills, because as of now, you have not demonstrated that you understand it very well. And so you want to focus your attention there. So this was the very first grade in the gradebook, was when we had practice and learning about how to go back and forth between the chemical equation and the sentences that they represent. So in question number 3, it asks us to do the opposite. So we put a chemical equation and wrote it as a sentence, and now we want to change the sentence that they've provided into a chemical equation. So we can do this. They say 1 mole of N2 gas. So N2 is our chemical, and it's a gas. So I put a G in parentheses. Now, normally I would put the number of moles in front and I would put a 1 there. However, chemists are kind of lazy when it comes to the number 1, and we don't actually write anything. So we would leave it blank. So the 1 is represented by this blank here. And then we've got, well, the 1 mole, all of that. The N2 is our formula. And the state of matter is right here. Now, the is reacting with, that's basically and, right? So that's our plus sign. And I'm kind of color coding this so that you're really seeing what words are being represented by which symbols. So now we have 3 moles. Well, 3 is not the number 1, so I'm going to write it. So 3 H2 gas. So we can see that we've got our chemical, and again, we've got a gas. Now, sometimes, I know earlier we said that the word aqueous or solid or liquid goes in front. We don't always do that with the word gas. That's kind of the exception. But just so you're aware of that. And it says, and makes. Okay, anytime you're separating what you were reacting together from what you're making, that is your arrow. Okay, that is your arrow. You're saying that the nitrogen and the hydrogen are coming together and they make, in this case, one thing. They make 2 moles of NH3 gas, which again is that G in parentheses. So I forgot to highlight this 3. So we've got the 2 moles is represented by the 2, the NH3 is our formula, and then we have our state of matter, which is our gas. So hopefully the color coding can help you really see how the word and the chemical equation are connected. So now we will get into skill number 2. So the second skill we learned about was writing mole ratios. And when you're writing a mole ratio, you use the number in front of each chemical formula. And this is called a coefficient. Oh, I really needed to zoom out. This is called a coefficient, and that blank is way too small for my handwriting. So I'm going to write it here. So it's called a coefficient, and we already talked about that. So those coefficients in front of our chemical formulas, which again are these highlighted in green in this question 3. And when there is no number in front of the chemical formula, we assume that there is a number 1, right? And so we want to write our mole ratios as a fraction to use in a T-chart because that's typically how we use them. But I'll show you the 2 different ways. So let's look at this example. In the equation below, what is the mole ratio between nitrogen and hydrogen? So these are the 2 chemicals. That means what I'm looking at in my formula is hydrogen, and I'm looking at nitrogen. I can ignore the NH3. I don't need to look at it because it's not part of this question. It's extra information. And so I know that in front of nitrogen, there's no number, and so that means there's a 1. So I can write my fraction or my mole ratio as saying 1 to 3, like that. This is, when you write it in this form, that's called a proportion. And you're saying that these 2 numbers or these 2 quantities are related to one another through some way, in this case, our chemical reaction. But most of the time, we use mole ratios as a fraction. And so when we write it, we can write it as 1 mole of nitrogen over 3 moles of hydrogen. Now, this would be the correct answer for this particular problem because the problem lists nitrogen first, so therefore nitrogen has to be in the numerator. But when we're working with the T-chart, sometimes we need the mole ratio between a chemical and we want nitrogen to be on the bottom. And in which case, you can flip the fraction to where 3 moles of hydrogen is at the top and our 1 mole of nitrogen is at the bottom. Okay, so I want you to be aware that these fractions can be flipped because they're equivalent to each other or they're related to each other in this way. So if you need more examples, you can look at your independent practice on eClass, and you can look, pretty much you can Google mole ratio practice problems and you can find stuff online. But you can also ask me in class and I'd be happy to give you a couple extra problems if you want them. So the third skill was actually using these mole ratios to be able to convert between chemicals. For example, if I know that I want to make cookies for all of my classes on the day of final exams, I need to know how many students I have, how many cookies I need to make, and I can work backwards. I can say, okay, if I need to make 100 cookies and my recipe says that I need 1 egg for every 10 cookies, that means I need 10 eggs, right? Well, that kind of math is what we do, but for chemical reactions. Because if I'm trying to make a certain amount of a chemical, I need to know how much of my ingredients I need. And so that's what we use conversions for. And so we're kind of separating them right now into their individual pieces. So mole ratios are used when the given and what you're looking for in the problem have different chemicals. Okay, this is when they have different chemicals. And it's recommended by me that you write your mole ratio as a fraction before you set up your T-chart, because that makes it so much easier on your brain when you're trying to think through your chart. Okay, so our question says, in the following reaction, nitrogen gas plus 3 moles of hydrogen gas produce 2 moles of NH3 gas. How many moles of hydrogen will be needed to make 1.36 moles of ammonia, which is NH3? So remember, when we start out these problems, the first thing we do is we label what we're given and what we are looking for, or what we're trying to find in the problem. So your given is always the number and the unit and the chemical that is provided for you. They're saying you're starting with this. I want to know something else though. And so that number is our given. And so I'm going to keep it highlighted as yellow the whole time. So it's 1.36 moles of NH3. And so that is our given. Now what we're looking for. You always know what you're looking for because find your question words. So here it says how many. Okay, how many what? Moles of NH3. So we know that what we're looking for is moles of, not moles of NH3, moles of H2, of hydrogen. That's what we're looking for. And so our goal is to say, okay, well, if I'm starting with this much, how much of that other thing did I need to have? If I need to make 100 cookies, how many eggs am I going to need to make that? That's basically what we're trying to solve here. And so when we do this, how we know that we need to use the mole ratio is because these chemicals are different. So when we look at NH3 and H2, because the chemical and what you're given and what you're looking for are different, that means you need your mole ratio. And so what we're going to do is we're going to say, okay, if I know I need that, let's go ahead and write it out. What is my mole ratio going to be? Well, I know that my chemical NH3 in my given, in my question or in my equation has a 2 as a coefficient. So that means I'm going to write 2 moles of NH3, and I'm going to put hydrogen, which has a coefficient of a 3, underneath it. 3 moles of hydrogen. And so what this is saying is that if I want to make 2 moles of NH3, I have to start out with 3 moles of hydrogen. But we don't have 3 moles of hydrogen, or we don't want to make 2 moles of NH3. I want to make 1.36 moles. And so that's the difference. We're using it to set up our problem. So we set up our T-chart to make our conversions, and what we're given goes in that first spot right there. So we have 1.36 moles of NH3. And I know I need to use my mole ratio, but how do I know if I need this fraction or if I'm going to need to flip my numerator and denominator? Well, this is where the pattern comes in. When you make conversions, you're basically setting up your proportion so that your units and chemical cancel out. So whatever chemical and unit you have in your given needs to appear in the denominator of your fraction. So this would be moles of NH3. So when we look at our mole ratio the way we wrote it, we see that moles of NH3 is at the top. So we're going to have to flip our fraction. So we're going to put 2 moles of NH3 at the bottom and our 3 moles of hydrogen at the top. And so what this results in is the moles of NH3 canceling out. We have moles of H2 left, which guess what? That matches what we're looking for. So we know we don't have to go any further. We don't need any additional fractions. We have what we need. So just like you were to set up, which because I know that students who maybe are not in my class but have a different teacher might be watching this video, this is the same setup. In case your teacher set it up a little bit differently, this is the same way as setting it up like this, where you just say you're multiplying by the fraction and it's set up like this. That's the exact same thing. Except instead of this X, I just put the T-chart like that. But we do the same sort of math. You always multiply by the numbers at the top, and you divide by the numbers in the bottom. And that would be the same here. We would multiply by the 3 and divide by the 2. So in your calculator, you always want to start with your given. So you have 1.36. And then we're going to multiply by 3 and divide by 2. And so when you do this, you should get 2.04. Now that's our answer, but your answer always has to include your unit and your chemical formula. Now the only unit and chemical formula that did not cancel out in our T-chart is the words moles of hydrogen. So that is our full complete answer, is 2.04 moles of hydrogen. And because it is 7:20, I'm going to pause the video. For me, it's about 20 minutes now, and we're going to do stoichiometry part 2 next.